So here in example 3, we have another improper integral, negative infinity to 0, x over 9 plus x squared quantity cubed. So this is still type 1, infinite interval, but our problem is with the lower limit becoming infinite instead of the upper. So we're going to do something similar to what we did before. We're going to replace that minus infinity with a number a. So we'll integrate a to 0, finite interval, of x over 9 plus x squared quantity cubed dx, and then we'll take a limit as that a approaches minus infinity. So if you sketch the graph of this function, it looks like this. So what we're doing is we are integrating starting at 0. We're going out to a negative number a. We're finding that area, which is a finite area, and then we're letting that a approach minus infinity. And we're seeing if that infinitely long strip on the negative side is going to be finite or not. So, well, this is not a basic integral, but I do see a function here, 9 plus x squared, and then almost its derivative on top. So let's try a u substitution here. U equals 9 plus x squared, and then our du would be 2x dx. Now we've got the x dx here, so let's multiply by 2 and compensate outside with a 1/2. So 2x dx, that's our du. So now this becomes limit a is going to minus infinity. And then we got a 1/2 outside our integral. And then on the top we've got du, and in the denominator 9 plus x squared is u, and it gets cubed. And then we have to change our limits of integration over also. So if x is equal to 0, then plug that in here. 9 plus 0 squared, u will just equal 9. And if x is equal to a, plug that in for x, so u would just be 9 plus a squared. So our lower limit is 9 plus a squared, and our upper limit is 9. Now u to the negative 3 is the same as 1 over u cubed. So we're really integrating u to the negative 3. So we want to increase the exponent, divide by the new exponent. So this will be limit a goes to minus infinity. Got a 1/2 out in front. And then our antiderivative of u to the negative 3 is u to the negative 2. Divide by negative 2. And we are going to evaluate that from 9 plus a squared to 9. So this 1/2, negative 2 in the denominator, that's a negative 1/2. We can factor that outside of the evaluation and put it with the 1/2 that's out in front. And then u to the negative 2 is 1 over u squared. So we can rewrite this as limit a is approaching minus infinity. Got a negative 1/4 out in front. And then we are just evaluating 1 over u squared from 9 plus a squared to 9. So the reason we can factor out that constant again is distributive property, because we would plug these two in and subtract, and both of them we've divided by negative 2, so we just pulled that out in front. So this will now be limit a goes to minus infinity, negative 1/4. And now if we plug our 9 in for u, 1 over 9 squared is 1 over 81. And then plug 9 plus a squared in for u. So 1 over 9 plus a squared. And that gets squared. So as a goes to minus infinity, our a squared goes to infinity. 9 plus a squared quantity squared, that whole denominator goes to infinity. So this piece here approaches 0. So that limit is going to be negative 1/4. And then 1 over 81 minus 0. So we've got negative 1 over 81 times 4, 324. And so we see that this is not negative infinity. So that means this infinitely long vertical strip has finite area of 1 over 324, and it's below the x-axis. So that's how we treat negative infinity in improper integral.